want to solve this system by substitution, and when you're trying to solve by substitution, you take one of the equations, solve it for one of the variables, and then take that expression and put it into the other. Well, in this case, one of our equations is already solved for us, so we already know that in our ordered pair solution, the second coordinate is going to need to be -2. So all I need to do now is find x, and I'm going to do that by plugging this -2 into the y. So I have 4x minus 7 times -2 equals 22. So 4x plus 14 equals 22. Now I'm just going to solve for x by subtracting 14 from both sides. So 4x is equal to 8. Divide both sides by 4. So x is equal to 2. So the solution is 2, -2. Here I have a plane that is flying with and against the wind. So whenever you have a problem like this, sometimes you'll see ones with boats and rivers where the boat goes upstream and downstream. What we're going to do is we're going to say, okay, this is the wind, and it has some speed. So the wind is W miles per hour. Okay, and on the trip with the wind, the plane goes 238 miles per hour. So this is the plane. I'm going to do a not incredibly great drawing of a plane. When it's going in the same direction as the wind, it does 238 miles per hour. When it's going against the wind, so let's draw another plane. This one looks even worse. It goes 222 miles per hour. So you can see that when it's going with the wind, it goes faster, and when it's going against the wind, it goes slower. The reason it goes faster when it goes with the wind is you take its regular speed and add the wind to it. So if we let p equal the plane speed and w equal the wind speed, then when it's going with the wind, we would say the speed of the plane plus the speed of the wind is equal to 238 miles per hour. Now this one, when it's going against the wind, this is decreasing the speed. So that means it's the speed of the plane minus the speed of the wind equals 222. So I'm going to solve this one by using the addition method. The reason I'm doing that is if I did that, these two would already cancel each other out. So if I add these two equations together, column by column, I would have 2p plus 0w equals 460. Okay, so that means 2p equals 460. So now I have an equation with only one variable, and I can easily solve that for p by dividing both sides by 2. So p is equal to 230 mph. Okay, so the speed of the plane, if there were no air current, would be 230 miles per hour. So if I want to find the speed of the wind, I just need to find out, okay, well, what number had to be added to that to get 238, or subtracted from this to get 222. So I'm just going to take either one of these equations. Let's start with let's just do the p plus w equals 238. And plug this p into it to find w. So 230 plus w equals 238. So if I subtract 230 from both sides, we'll see that it's 8. Generally, when you have a word problem like this, you do not write the answer in ordered pair form because it's difficult to tell which one is the independent and dependent variable. So you just leave it in this form here. Okay, here we have two schools that have rented buses and vans. Okay, the first school rented 6 vans and 10 buses, and they had a total of 636 students. The second one had 5 vans and 6 buses, and they had a total of 397 students. So We're assuming that the buses and vans are completely filled, and we want to figure out, well, how many students fit in the vans and how many students fit in the buses. So I'm going to start by letting V equal the number of students in a van, and B is going to be the number of students in a bus. So I'm going to use the ditto marks here so I don't have to write that again. Okay, so let's look at high school A. So they rented 6 vans and 10 buses and got and they got 336 students. So what they have here is 6 of the number of students in a van and 10 of the number of students in a bus for a total of 636 students. So I can represent that by 6 times the number of students in the van plus 10 times the number of students in a bus equals 636. Okay, so I'm going to do a similar thing for the high school B. They had 5 vans and 6 buses. So 5 vans plus 6 buses equals 397 students. Okay. Now I can solve this one in various ways. I'm going to solve it by using the addition method. The addition method, when you're using the addition method, you want the coefficients on the variables of the two equations, of one of the variables on two of the equations, on the two equations, excuse me, to cancel each other out if they were to add up. So they need to be opposites of each other. The easiest way to do that when they're completely different, you know, one's not the multiple of the other, is to multiply each of these equations by the coefficient on the other equation. Also, one needs to be negative and one needs to be positive, so when you add them up they equal 0. So I'm going to multiply the top one by -5 and the bottom one by +6. Now it doesn't matter which one of these I made positive and which one I made negative. I just decided to make the top one positive. I'm sorry, negative. 6b plus 10b equals 6. Now you gotta make sure you multiply both sides of the equation by that variable, or I'm sorry, by that number, by -5. So 5v plus 6b equals 6 times 397. Okay, so if let's number these. This is the first one and the second one. So 1, 2. So let's find out what I get in equation 1 when I distribute the -5. I'll get -30 v minus 50 b equals -3,180. Okay, now let's do equation number 2. If I distribute the 6, I'm going to get 30v plus 36b equals 2,382. So once you get the two of the coefficients to be opposites of each other, then you can add the equations together. That's why this is called the addition method. And you do it column by column. So I'm going to add these v's together, and we'll see that that gives me 0v, which is good because I wanted one of them to have a coefficient of 0. And then minus 14b equals -798. Okay, so what I have is the equation -14b equals -798. So I have an equation with only one variable that I can solve just by dividing both sides by -14. So b is equal to 57. So now all I need to do is find v, and the way I'm going to do that is by substituting this b into either one of these original equations. Okay, now you want to make sure you always use an original equation in case you made a mistake here somewhere. That way, you won't have two mistakes. Okay, so let's just use the second equation. 5v plus 6b equals 397. And I'm just going to substitute this b in there. So I have 5v plus 6 times 57 equals 397. So 5v plus 342 equals 397. So if I subtract 342 from both sides, I'll get 5v is equal to 55. And then divide both sides by 5, I get v is equal to 11. So remember what this represented. V represented the number of students in a van, and B represented the number of students in a bus. So V would be 11 students, and B would be 57 students. Okay. Here we have a school that's selling tickets, and we're trying to determine from this data what the price of an adult ticket and what the price of a child ticket is. So what I'm going to do is let A equal the price of an adult ticket, and C will be the price of a child ticket. Okay, so on the first day, they sold 5 adult tickets and 12 child tickets, and they got $178. So what that means is they did 5 times the price of an adult ticket plus 12 times the price of a child's ticket, and that equaled $178. On the second day, they got $83 by selling 4 adult tickets and 3 child tickets. Okay, so 4 times the price of an adult ticket plus 3 times the price of a child's ticket is equal to $83. Okay, so here are my 2 equations. This one would come from the data in yellow, and this one would come from the information in turquoise. Okay, so what I'm going to do is solve this by the addition method. Whenever you use the addition method, you want the coefficients on one of the variables to be the opposite of each other in the 2 equations. So whatever this coefficient is, I want this one to be the opposite of that. So the easiest way to do that is to multiply the top and the bottom by the coefficients on the opposite, on the other equation. So this one by 4 and this one by 5. And one of them does need to be negative. I generally just make the top one negative, so I'm going to multiply this one by -4. Now you need to multiply both the left and the right hand side of this equation by that. And I'm going to multiply this one by +5. Okay. So what I want to do now, and let me do some color coding to make it a little easier to see what's going on. Okay, so I just want to distribute that -4 in the yellow equation, so that would be -20a minus 48c equals -712. Excuse me. And if I distribute the 5 here, I'll have 20a plus 15c equals 415. Okay. Now the reason it's called the addition method is because you just add the 2 equations together. Now when we add them, notice the coefficients here will cancel out, giving me 0 times a. Then if I add these 2, I'll get -33c. And if I add the constants, I'm going to get -297. So what I have here is -33c equals -297. So I have an equation with only one variable. And I can easily solve that just by dividing both sides by the coefficient on C, which is negative 33. So C is equal to $9. Okay, you don't want to forget your unit of measure. In this case, it's $1. Okay, so 4A plus 3C equals 83. What I'm going to do now is take this value of C and plug it into either one of these equations. I've just chosen the second one because it has smaller numbers. So I'm going to plug C, which is 9, into this equation. So 4A plus 3 times 9 equals 83. So 4A plus 27 equals 83. Subtract 27. So 4A is equal to 56. Then divide both sides by 4. So I get A is equal to 14. So what I have here, remember A represents the price of an adult ticket. So the price of an adult ticket is $14. And the price of a child's ticket is $9.